Good morning, everyone. We'll just give a few more minutes here for some of our customers to join in, and we'll get started shortly. All right. Good morning, everyone. Welcome to the TriStar webinar series. My name is Thiagu Palaniappan. Today we'll be covering the ANSYS AIM product in our webinar. Mainly just wanted to focus specifically for the Creo users. This is our second webinar on the ANSYS AIM product. We previously did a webinar on the AIM product just to give you an overview of the product and its capabilities. And I just wanted to go over from an agenda standpoint, again, a quick overview for those who have not seen or heard about AIM, and also specifically talk about the guided workflows that are available in AIM for anybody. You don't have to be an analyst to do the analysis. It's meant for the designer and the engineer, right? You can also configure your CAD. It's mainly Creo Parametric if you're using that in AIM, so you can access it or launch AIM from within the CAD. And you can also expose the parameters, dimensions, what have you, for doing design exploration within AIM. Now, this meeting, it's going to be, everybody is muted. All the attendees are muted, but feel free to type in your questions in the question area or the chat session at the bottom in the GoToMeeting window. And I'll try my best to answer those towards the end of the session. Before we begin, just wanted to quickly go over some of our promotions that we are running. The first one being on the certified training courses through June of this year. And then also on the PTC MapCAD product, there is also going to be a promotion of that through end of June. And in our website, you could register for PTC's LiveWorks event. We'll have our PLM experts to help you with your questions at that event. So that said, let's take a look at what is ANSYS AIM. So as many of you have heard about ANSYS being, very, and they have sort of flagship products for simulation. This is a new product, and it's essentially an immersive environment, very easy to use for engineering simulation. It still has the breadth of ANSYS physics that we all know of, but it's a single and one environment, immersive environment. It's very easy to use. It has a lot of process templates, guided workflows, etc. So all the way from importing the geometry, creating the mesh, and then depending on the physics that you would like to simulate, right? It could be structural mainly, or it could be fluid, or it could just be both fluid structure interaction. So it also supports multiphysics. It could be thermal and structural, for example, and once you're done with your analysis, rather than just asking the how much questions, you're also able to run the what if scenarios using the design exploration, using parametrizing the dimensions that out of the geometry, regardless of whether it's coming from another CAD system or if it's a neutral file. ANSYS AIM has the capability for geometry editing, as well as parametrizing dimensions that you could run what-if scenarios. So like I said, it's one single environment. You can see the screenshot there, which essentially shows, it works, parts, assemblies, complex assemblies, simple parts. So you would essentially open that in your Creo environment. You have a Creo file, right, and then take it to ANSYS. And ANSYS has these process templates, right? So let's say you want to do a structural analysis only. All you're worried about is the stress and the deformation. You would just choose that template. Or if you're more into fluids, or if you have a multiphysics problem, you would choose that appropriate template, and it automatically gives you some guided workflows that you could choose, and it will just walk you through it, right? And if it's really not, it typically, you might have seen whenever we talk about any simulation tool, it's like it's meant for the analyst, or you'll have to learn multiple solutions or multiple tools. One may have structural capability, one may not have fluids capability or computational fluid dynamics capability. But in this one, you're pretty much able to select, in one environment, right? You're able to do both single physics and multi-physics simulation. As soon as you select the template, like in the example here, when I select a structural template, you could see how AIM gives me, I picked the structural simulation process template, and it gives me the workflow associated to that. So it's just mainly essentially getting the geometry, right, editing it if required, creating the mesh, as you know, right, and then controlling the mesh if required, and then solving the physics, and then just viewing the results, right. Now, if I were to select a fluid structure interaction template, which is more on the multi-physics side, other than picking the geometry and doing the mesh, it requires two paths, as you can see there, where information has to go from the fluid analyses, right, based on your boundary conditions. It's going to solve for the fluid flow, and then it's going to export the results into structural, and then it's also going to do the structural analysis. So you could see that, you could see those, so here, this connection that you see here is included in the template automatically. So as a user, all you're going to do is you're just going to follow through these steps, right? It's going to prompt you, and it'll tell you attention required with that symbol in red, and you'll have to maybe generate the mesh, or you just have to update the geometry sometimes, right? So similarly, if you select fluid flow or thermal or electric conduction, right, there are specific templates, and in fact, you can even create your own user-defined templates. So if you want to deploy it throughout the company, right, for your specific simulation needs, you are able to create your own process templates as well. Now, on the geometry modeling side, if you're using your CAD system, yes, it has bidirectional integration with most major CAD systems, including Creo Parametric, but you can also bring in neutral files. It has the ability to edit geometry, quickly repair and simplify geometry within AIM using the space engine, and there's also design modeler for actually, it's more for exploration for what-if scenarios. So, for example, you want to extract the fluid volume, which in most CAD systems, it is quite it takes some effort, as you can imagine, to create a fluid volume, but you need that in a fluid flow simulation, and AIM allows you to, edit the geometry, extract volumes quickly using space claim that's included in the AIM license. Now, as for the CAD import and interfaces, this is something that I want to specifically focus on in this webinar. What you see there is essentially the different file types that you're able to import into ANSYS AIM, right? You just see Creo files, or Wildfire, or Creo Parametric files, including all the other CAD systems. If you happen to have Creo Elements Direct modeling, you can even import that. including most of the neutral files are supported. So there is like a reader license for all this that allows you to bring in these geometry directly into AIM and then create the mesh and then apply the boundary conditions and solve the physics and view the results later on. Now, when you install AIM, it actually gives you an option to configure the CAD. So if you didn't do that after installation of AIM, you are able to run the product config executable file, and that allows you to configure the CAD. All right, so you are able to select configure CADs right here, and that takes you to this dialog box, which essentially allows you to select. As you can see, it has all the major CAD systems, including Creo Parametric in there. And once you select, once you do your CAD selections, you essentially have to specify the installation folder and the startup batch file, right? The executable for Creo, as you can imagine, is parametric.exe. And once you point that, when you launch Creo, this is kind of what you're going to see, where you will be seeing in the ribbon tab a tab for ANSYS 17.0, all right? And that's the latest release. And from there, you could launch AIM, and it's going to bring up your model in AIM to do your simulation. Or you could be working on your Creo model, parts or assemblies within AIM. As it guides you through those workflows that I was talking about, you have the ability to connect to an active CAD session. So once you have configured your CAD, right, it understands that to browse and select, give you a list of the current parts that are available in the CAD, on the CAD side. For example, here I'm able to just select my TriStar.part.PRP, and I can bring that into AIM. And once you bring that into AIM, the next step, obviously the most important step, is it's good that I can run an analysis, but what about my critical dimensions? I might want to change the radius and see what happens. I might want to reduce the stress by increasing the radius or changing some dimensions. It could be a pattern dimension. It could be a regular feature dimension that you have in Creo. And you're able to expose that just using your, within AIM, you have the ability to expose or expose dimensions just by using your dimension name. So I have a fillet radius is my dimension name in my Creo model, and I'm able to expose that. And when you expose that, you also have the option to parameterize within AIM. So what the parameterize option allows you to do is create multiple design points. So let's say you ran the analysis with the current radius there. You are able to go and add multiple rows, as you can see here, right? I'm essentially creating different design points with different dimensions, and I want to see the output of the analysis based on those inputs, right? So you're essentially doing a design exploration at this point. And so at this time, ANSYS AIM is essentially using its design explorer, design modeler behind the scenes to do these changes at the same time. It is kind of linked to your Creo Parametric environment, where that's where you have your part or assemblies, and you can make changes to that, synchronize it back here. So really, the idea behind AIM, like I said, is to allow simulation for the engineer or the designer. But you don't want to be spending like days and weeks together on the setup and everything, right? You don't want to be learning multiple FEA tools to do different types of simulations. It's just one tool essentially. So once you bring in the geometry, whether you import or use a CAD interface, the next step is for the meshing, right? In order to do the analysis, obviously you need the mesh, and it has, the meshing capability within AIM is kind of like what it is, what you have seen with ANSYS products from their flagship products, whether it's mechanical, CFD, Fluent, etc. So wherein you have tetrahedral and hexahedral meshing, including support for inflation. So you need to account for the boundary layers, right, when you do a fluid flow simulation. and you have specific mesh control options, or you have global settings. You can have a fine mesh, coarse mesh, etc. And all that is supported within AIM for the geometry that you have imported or that you have just got from your CAD session. And then you can evaluate fluid performance, so steady state, laminar and turbulent flow, compressible or incompressible flow. They are supported, right? And again, all this in the template, it will walk you through how to set these up, in fact, right? Even though you could be a new user, it'll walk you through it. And there are predefined templates for each one of these physics simulations. Or sometimes you just want to do a pretty straightforward stress analysis on your assemblies or parts. It can detect contacts automatically. That's huge in assemblies, as you know, right? As you know, part level analysis is pretty straightforward. You bring in the part, apply a boundary condition, apply the load, and then run the analyses in most FEA tools. However, in large assemblies or medium complex assemblies where you need to look at the interface between the components are quite important, it can detect contacts quickly. And then you can apply your boundary conditions and look at your stress and deflection result. Same thing with the thermal side. You can simulate conduction, convection, radiation, heat transfer mode. And you can also couple this with other physics, right? Whether it's thermal, mechanical, thermal, electric, right? And all these, again, it's just following the guided workflow based on the process template that you have selected. There's also fluid structure interaction. So most products, as you'd imagine, they don't have one single physics. Like in that solar panel example, you obviously want to simulate the fluid flow or the load, the wind loading. For that, you need to do a fluid flow analysis. However, I'm also interested in capturing that pressure distribution or the force on the geometry and running a structural analysis and seeing if it's going to fail, what is the maximum deflection, and what is the stress based on the yield, etc. So when you do that, this is a good example where you would need multi-physics to work, or you need to couple them, and that's the fluid structure interaction template allows you to do that. And it could be the thermal also, right? To air cool, just simulation on that cooling fins on an engine. You can also, apply current density, temperature. You want to do some DC electric simulation. That's also supported. There's a specific template for that. And regardless of which simulation tool, or I should say the process that you use, which template you use, you do have full capability to view the results, right? And the most important thing as an engineer or designer that's currently working on your CAD system, which could be Creo Parametric, you want to see how to make design changes within your tool and propagate that to the analyses. And like I said, that's done using the parameterize option, where you are essentially exposing your dimensions and then using those design checkpoints, running a few scenarios here, and it's going to give you the results for those. So it helps you make some engineering decisions based on these, right? Rather than doing a trial and error, you're using the simulation results to help you with your design process up front. It also supports automation and customization. So like I said earlier, you are able to create user-defined templates. It supports, just like ANSYS flagship products, it supports full journaling and scripting capability. So like I said, it still works on the Workbench platform. However, it's the ease of use. That's the key here. It's one single environment that allows pretty much any engineer or design engineer to write, very, very, very less learning curve is what I'm getting at with the AIM tool compared to the full ANSYS products or any other complex analysis solution tool. It still has the accuracy. It has still the same power, right? The solver, the mesh. It's just that it's a lot more easy to use. Okay, so real quick, I wanted to just open up AIM and kind of show you. So this is the one you see the process templates. What I'm running is AIM 17.0, and the first thing I'm really presented with is selecting a template, right? Whether it's structure or fluid flow template. I could select a fluid flow template, for example. As soon as I'm done with that, I have the option again to connect to an active CAD session if I have Creo running, or I could import existing geometry, right? I can include additional thermal effects here. So, for example, the change in temperature of the fluid, right? I want to include that. And I create my simulation process. And the different file types you can see here that I can import right there, right? So it's Creo Parametric. You know, in this case, let's say I'm going to import one of the parasolid files here. What it's doing right now, you can see at the bottom, it's populating the workflow steps, right, based on the process template that I used. At the same time, bringing in the model as well, right? And those different colors there are telling you that some of them require attention, some of them don't require attention, etc. Right? So it's really a thermal mixer example. Let's say I want to stimulate, you know, I'm going to mix a hot fluid and a cold water, hot water, and I want to see, you know, the temperature. Obviously, I want to see the streamlines. I'm able to do that using this template, right? So let's say you could be a new user, for example, and you're going, okay, the geometry is imported. However, I do need a fluid volume, right? We might be having hot water here, cold water here, and then there's going to be the outlet. But what about the fluid volume itself, right? I'm able to go, and when I bring in my template, let's see here, when I go to create a new object, I have the ability to edit. So, for example, sometimes you may have the template, the fluid volume, but in this particular geometry, I didn't have the fluid volume. What I could do is I could say, I want full model editing capabilities. So what is it doing when I select the model editing capabilities is I'm not going back to my CAD tool. Within AIM, right, like I said earlier, let me just go and create that step one more time. I'm going to select my parasolid here. You have space claim that's included with the AIM license, right? That allows you to do quick geometry editing, repairing, defeaturing, and you could also bring in, you could also quickly generate the fluid extract volume. And once you generate the volume, what happens is you are able to control the mesh density for that particular fluid volume. You could provide inlet boundary condition and outlet boundary conditions. And once you do that, you're able to just, it'll just walk you through those templates there, the one that I was showing you earlier in my slides here. So the template that I'm going to import essentially is this guy here, right? I'm just using a, just like the structure, I'm just using a fluid flow template. And that's what it's populating right now, as you can see. But it also will give me the ability to edit the geometry. Now, you could always edit the geometry in Creo Parametric and run it live that way, right? So right now I do have the part, but I want the ability to edit the geometry. So before I just import it without the ability to edit geometry, and now when I say edit geometry, see how I'm able to switch back and forth between the AIM simulation environment and the modeling environment right here, right? So now so Space Claim is behind the scenes. That's the engine that's working here. And here I'm able to do, right, as you can see, regular editing features, move, pull commands. I'm able to prepare my model for simulation. For example, I want to do a volume extract here, and I'm going to select, for example, these three surfaces. And I also want to select the feed surface here. So let's say I want to go select, this is my, and I can just create the fluid volume based on that. So let's see if I can pick my and once you generate, yeah, so that's the one, the outside surface, we don't want those. And then I'm going to get into my capping surface here, the feed surface. And once I can just generate my fluid volume. And once you generate the fluid geometry, just let me just exit from here. Let me go back to my AIM, and I'm going back to fluid volume here. And what I could do is, let me just go back and do the volume extract one more time. And you see the inside, like the feed surface that it can get, because it's something that in most CAD systems, to get the inside volume, it might be really complicated. But here, what I'm going to do is I'm just going to select the inside volume here, and it's generating the fluid volume right now, and you can see how it was generated in quick time. And I go back to my editing geometry, and it's going to synchronize to AIM. So if I were to go to my geometry and quickly hide the body, you could see that it has generated the fluid volume, right? So I mean, rather than think of AIM as just for your simulation, you also have a lot of defeaturing capabilities and extracting volume capabilities, which is huge when it comes to fluid flow. Now, I also want to be able to go back to the mesh and generate a mesh now. So this is where you see how it guides me through. It tells me that the geometry is fine, right? And I can go to my mesh, and I'm able to see when I do a right click, it's telling me that you got to fix the inflation. So inflation is typically the boundary layers, right? So between the fluid and the solid, that that's where we use it to improve the accuracy, as you can. So you can control that. I could say I want for the entire model, right? So I can essentially go and pick the entire surface there, and I can just deselect. You don't need boundary layers of the inlet and the outlet, right? And I can control the inflation parameters, and I could say, let's create the mesh. So all I'm really following is that guided workflow at the bottom. And now it's telling me, so the geometry and the mesh is done. I just need to solve the physics, essentially, right? So when I go to the physics, I can add boundary conditions. I can add inlet, outlet, etc. Right? So within, again, the selection techniques here, you see, as you can see, the ease of use is what I want to show you. So when I select any of the surfaces here, so for example, I want to be able to select a surface, and I want to add a boundary condition to that real quick by saying, okay, that's one of the inlets. So when I click on that command, right, it automatically gives me, as you can see, dialog boxes right there where I can control. I want to specify velocity and temperature, for example, there, right? So maybe I want to set the velocity is so much meter per second. I want to go into temperature and say I want to assign maybe 30 degrees, right? So I'm just going to give now similar to that. Again, clicking on that, very straightforward. You have like breadcrumb style information here. As you can see, it's showing you the steps, also the dialog boxes here, but all you're doing is just following this template here, right? Or the tasks in your workflow. Similar to that, I'm able to go select, add another boundary condition for the inlet here. So that's where I want to add, for example, it's going to be hot water is what I want to add. So here I'm going to, let's say I want to give a certain velocity, and I also want to assign a certain temperature. Now, when I assign this temperature, though, I might want to later on run analyses when I change the temperature, right, to different values. So what I can do is at this point, I could parameterize it. So I have a little parameter option here. So I'm saying that this could be a future design checkpoint, right? It's going to be a design point for AIM, wherein I want to change these after running my first run and see the effect and see the result there, right? So similar to this, once I've added those, I'm going to go to my outlet, and I'm going to specify that as my outlet condition. Right. Again, I can just say, I can just say it's 0 Pascal for now. So having specified these, right, once I specify all these, if I go back to my physics, and you see how it is, you have the physics region. If you go to the material assignment for the fluid volume, you could just type in, it's just like applying material properties on the structural side. It has a library. It gives you all those that you have used before, or if you just type in, right, so as you can see, water fresh, you have different seawater, etc. You have different properties. So if I go to, once I select that, if I go to water, there it is, right? It has all the properties for it. Now, when I go back to the physics, as you can see, it says that some attention is required, right? So again, it walks you, it helps the user. It lets you know if that particular task is complete or not. I can go to my boundary condition here. I have inlet, I have outlet, right? I have those. Go back to my physics here. And if I go to the physics region, right, that's where, look, I'm going to just select the volume. So instead of the face, I'm just going to go to the body selection. That's the body I want. I'm going to replace that. So, and once I've added the once I've added that, now I could essentially solve the physics, right? I can just go and solve it. Before I solve for this, what I'm going to do is, let me go bring in. So the one I'm going to bring in is going to have the same template and everything, but the physics is solved. Then we'll be looking at the resource interface. While we're waiting for that to load, let me see if we have any questions. The question is, which version of Creo Parametric is supported? Is wildfire supported? Yes. So during the configuration, Creo Parametric 1, 2, 3, as well as wildfire 4 and 5, they are supported as long as you point to the install location and the startup batch file, you should be fine. So here, as you can see, I've solved the physics. If I go to my results, you'd be interested, obviously, in the velocity vectors, the streamline. If I go to my streamline, I can animate the streamline. And I just want to see the flow from the top to the outlet here. I could also, similarly, I could show the temperature profile So if I go to my results, I want to look at the contour of the temperature. You could create planes on the fly on the cylinder and say, I just want to have the temperature profile. That's it. Now, once I'm done with all this, I might want to change. Remember, we added a checkpoint to that temperature. So if you look at the physics, we added a few boundary conditions, right? Wherein I have to specify, the temperature, right, for the second one right here, wherein we had parameterized that. So that allows me to take this model into a design point dashboard. So what the design point dashboard allows me to do is provide different temperatures, and then I want to see, for example, the temperature based on the outlet, based on the inlet water temperature, right? So this is where I'm doing design exploration. Now this could also be from Creo, right? I just selected a boundary condition value, but in Creo you could expose a dimension as long as you know the dimension name. You're able to expose that here. Okay, so with that said, let's get to Q&A session here. So if you could start typing your questions, I'll try my best. I know we went a little beyond here, or 30 minutes, but it'll take a few more minutes. And then we'll go through your questions here. All right. As for the cost of one seat, there was a question about how much does one seat cost. Yeah, please check with your account reps at TriStar, and they will be able to help you with that. How is the solver speed for AIM? Does it use the same solver as Workbench does for CFD or structural mechanical APDL? It's a great question. So for on the structural, yes, it is using the same mechanical APDL. And as for the fluid side, right? If you think about Workbench, right? It's still working on the Workbench platform. It's just that AIM is more of an environment on top of it, wherein they are giving you these process templates and guided workflows. That's pretty much it. Will there be a replay of this webinar? I was pulled away a couple of times during the presentation. Yeah, absolutely. In fact, we have all our webinars in our website under Resource Center. If you go to CAD, that's where we have all. This is the second webinar that I'm doing on ANSYS specifically, but on all the other products, whether it's Creo or Windchill PM Link or the PLM side. In our website, if you go to the Resource Center under CAD, all these are being recorded actually, so you can review them. Also, are the ACT extensions from Workbench compatible with AIM? Acoustic extension would be nice to have. That's a good question. Yes, ACT extensions are that are compatible with AIM. However, I doubt if the acoustics are supported in AIM as of yet. But compared to 16 release, 16.0 release, and 17.2, and then now 17.0, they are trying to include, for example, electromagnetics was included as a beta release, but moving forward, that might be included. But I don't think acoustic extension acoustics is supported yet within AIM. Is there a way to create a volume extract in Creo so as to avoid learning space claim? That's a good question. Yes, you can. However, you have to be good at surface modeling. If you know how to, we don't have, as you know, within Creo Parametric, a direct fluid volume extract option. You have to do a copy surface, right? You'll have to do an all solid surface copy. And then using seed and boundary option, for example, quickly, and then you'll have to get rid of surface that you don't want. So it's not as simple as the space claim that's built into. It's just the engine, right? You really don't. It's just that you're getting into an editing environment with an AIM, and that allows you to select, just select the outside surfaces and the seed surface inside seed surface, and it knows to quickly give you the extract, volume extract, compared to most CAD tools, wherein it's a little bit of effort. It can be done, but it requires some surface modeling, some geometry selection techniques involved in there. What are the benefits of ANSYS AIM over Pro-V or Creo Mechanica? Great question. Like I said earlier during the presentation, instead of learning different simulation tools for each simulation type, for example, you want to do a fluid structure interaction, or you want to do a thermal analysis where you want to simulate the fluid flow, traditionally we have seen customers buy one tool for structural and another tool for fluid flow, and then it's like trying to learn multiple SEA systems. And I believe with AIM, it helps you through that, wherein if you need multiphysics compared to just single physics structural analysis, if you have multiphysics, wherein you're not trying to learn these multiple FEA systems, you have one single tool that's easy to use, like I showed you, but at the same time, it has the power, it has the depth of ANSYS flagship products, right? But at the same time, you don't have to be like a traditional analyst or the FEA expert or the guru that we normally see in companies. You could be the designer and the engineer, and the process template guides you through that, right? So in my view, that's the biggest advantage with multiphysics and using one single tool for all your simulation needs. Can you use APDL snippets with AIM? I believe you can, but I'll have to reconfirm with you on that. Also, space claims same as design modeler. It seemed to be much better interface-wise. I'd say no. Space claim, as you know, right? I mean, within AIM, when you buy AIM, right? Let's say you buy a seat of AIM, you do get access to space claim and the design modeler or design explorer, for design exploration. So the design modeler is used more on the parameterized. Remember, you can create design points to do design exploration. That's when that is used. However, the space claim engine is mainly used for editing, cleaning up geometry, etc., and moving forward. Yeah, that's the focus. So yeah, you're right. That's the whole point, since it's easy to use. This is a very powerful tool. Okay, yeah, powerful at the same time, easy to use. That's the comment. What is the biggest difference between using Creo Simulate and ANSYS AIM? Okay, so the biggest difference, if you are currently a Creo Simulate user, you have been doing structural analysis, right, mainly. And when it comes to structural and thermal interaction, or when it comes to fluid flow and thermal, where, for example, you might want to simulate a forced air convection, where instead of typing in a heat transfer coefficient, just like that, right, you are able to simulate that using that fluid structure interaction or fluid thermal interaction template, right? That's the biggest advantage or the biggest difference. And ANSYS obviously has a lot more breadth in the physics side, right, with electric conduction and also electromagnetics being introduced as a beta release in AIM, right? You could see that it has a lot more breadth compared to Simulate, which is primarily meant for structural simulation only, right? Also, AIM has, on the structural side, it has SN and EN-based fatigue or durability studies. That's also included in AIM. So that's something that on the Simulate side, it's a separate license, right? Question, can this analyze ball bearing point contact? Very good question, yes. And what you could do is when you have the analysis, right, when you run the analysis, or I should say when you bring in your geometry, if it's an assembly geometry, you have the ability to automatically detect contacts, right? It is going to, yeah, once you detect, so as long as you bring in the assembly and then say detect contacts, it's going to do that, yeah. But if you need a lot more, I mean, so no sliding effects, right? If you need sliding effects, etc., that's when you would need the ANSYS flagship products compared to AIM. I think what are the greatest advantages of AIM versus advanced simulate? Yeah, I think I already answered that, right? The two small questions on the difference between AIM versus simulate. Is it solid in capability sets? Segments of FEA-CFD are sold, I'm sorry, is it sold in capability sets or sold complete with all physics modeling capabilities? Okay, it is sold as, I mean, AIM, it's just one, it's sold as one complete product, and all the physics templates, the process templates, and the workflows are included inside of that. So it's not like, you know, there's a license for CFD, there's a license for structural, you know, right? It's all inclusive, including, like I said, the space plane, editing engine, right? Design Explorer, they're all kind of included in AIM. How do ANSYS AIM contact elements compare to bonded joins in Creo? Okay, great question. In Creo, as you know, with Simulate, when you create, when you have two surfaces touching each other, it assumes it's bonded, right? And we use, as you know, the P-mesh. However, ANSYS is more of a H-element solver. So it uses, so when you get into nonlinear type of analysis, it has better mesh control on that end. So that's the difference between on the Creo side versus from an element standpoint or from a mesh standpoint, AIM versus the Creo Simulate side on the different types of mesh that we use, right? It has support for polyhedral mesh, you know, all the different mesh elements to improve the accuracy of the solution. How does you compare Creo simulation and AIM? Can they be used together, or what is the optional optimal workflow? Yeah, so I think I already, you know, there were quite a few questions on the differences between simulate versus AIM, which we talked about. But can they be used together? Yeah, absolutely, right? I mean, if you, for example, if you have simulate currently, you know, but then you do want to access AIM, all you do is do the CAD configuration steps that I showed you, and you're able to run it. So the optimal workflow obviously would be to make sure you use AIM. You want to use AIM mainly if you are going to use multiphysics as well as single physics. However, simulation, it allows only single physics structural simulation, right? That's really the difference. Can you still open your AIM project in Workbench independently? That's a good question. Yes, you should be able to open that independently. I mean, you could open Workbench files in AIM, and as long as it's on the supported version, you should be able to open it. If you have not been able to find a software to provide accurate results, there's a, I guess it's a comment there, but just a comment on that is, you know, before, when you do, you know, all these solutions like AIM, you know, they go through extensive validation by ANSYS, right? And there are validation documentation that's available. So as long as the user is trained or knowledgeable enough to apply the boundary conditions, and you're applying as close as possible to the real-world boundary conditions, you should be able to get accurate results that match the reality of real-world tests. And that's the whole point of doing simulation, right? We're not able to do, I know that we tend to sometimes believe our hand calculations on simple problems, but when it comes to much more complex geometry, you're unable to do a hand calculation, and that's why we rely on these softwares. But again, it depends. It's more like, you know, the input that you give to the software is important. The accuracy of the software is also important, and I know AIM has validation, has gone through extensive validation, and as you know, ANSYS has been there for quite a lot of years now, and they have a lot of flagship products wherein that's already proven, all right, and it's using the same technology behind the scenes. If you think about it, it's just that they have an easy-to-use environment. Will ANSYS override the application already built into Creo? No, I mean, remember when you run, when you go into application, you're not going to the applications tab of Creo Parametric. You know, ANSYS is just another tab once you configure it that it creates, right? I hope that was a question about the application tab, or I'm not sure if this is more related to when you run the analysis, you already run and simulate. Those are two different simulations, so you're not really overriding or anything here, right? But you can, I mean, on the CAD side and on the simulation side, you're able to link both of them using that active CAD session. Would you be able to do mixed media where half of the pipe is filled with water and half with air? Absolutely, as long as you have those fluid volumes generated that way and you can specify material properties based on the fluid volume. Yep. In Mechanica, the fatigue analysis and MD option is costly add-on. Does AIM have these add-on options, or all these steps now included? That's a good question. Like I said, the durability, they call it durability analysis in AIM, and that's included within AIM. But as for the MDO option on the mechanism dynamics option, that's more of a rigid body dynamics, and that is not included in AIM. Could you do an analysis where exhaust gas being pushed through a tube and have water sprayers in the tube spraying a mist of water cooling the exhaust gas and exhaust tube? It can be done, but I'm not positive it can be done with AIM though. I'm thinking it might need a lot more of a full flagship, full solution like CFD or Fluent from ANSYS. I like to see if they will add more templates in the future versions of, for example, LS Dyna, random vibration modules, popular workbench modules, simulation. Is that what ANSYS is planning on doing? That's a good question for ANSYS, actually. Yeah, I know that right now, the roadmap, at least as we hear from ANSYS, is to try to include additional capabilities. But as of now, like I said, with that electromagnetics was included as a beta release, but that could be for future. We don't know, but we need to check with ANSYS on that, and we'll get back to you on new templates. Does the license float, or is it locked to a workstation? It should. I'm assuming that you should. It's based on a license manager, right? Just like you have in Creo, you have an ANSYS license manager that you should be able to put it in a network and allow users to access it. Does the Design Explorer in AIM same as Workbench? For example, integrating the goal-driven optimization process with MATLAB, etc. possible? It's a good question. Yes, it is. Actually, if I open AIM, you will be seeing the Workbench platform. If I click on the project, you will really see Workbench behind the scenes. So it is like I said, it's just the user interface is the biggest change, or is an improvement in AIM as compared to Workbench. It's still working on the Workbench platform. However, it's just having these guided process predefined templates, and a lot more easy to use with right mouse clicks, user brain prompted, so the new user can pick it up really fast. All right, so looks like we are done with the questions here. Just before we wrap up here, just a quick reminder on the offers that we are running through end of June. Is on the training courses on PC product, and also on the MatCat promotion. and as well as the live event, PTC's in June in Boston, as you know, LiveWorks, and PTC's running that, and we have information on the registration. And please remember to meet our PLM experts from our team at this event. All right, that said, thank you all. Thanks for your time, and hopefully that gave you some information on ANSYS AIM, specifically to Creo's integration. And we'll be running more of these on the ANSYS products. Let us know if you need any specific topics that you would like to see in future webinars. But until we see you in the next webinar, you all have a great rest of the day, and thank you.